little trip, was to Fujairah. Well, we had 2 investigations to do there. We had one was to pretty much analyze the risks of flooding. So we went to Wadi and Safi. So we got to Wadi and well, we got in the car and we were pretty much going over what we had to do.
We try and work out basically how much water the Wadi can hold before it floods. Now, I don't think there would ever be a time when the Wadi had that much water that would come over the bank of it. But we're going to look for evidence of, let's say, the last line of water to see basically how much water was in the channel at that time. So we're going to do a cross section.
So for field work, we did cross section.
We did a transaction rate.
We took a transact at 2 points, which is the same points which
was basically a point in the source, a point in the map.
Yeah, which we did like all 3 of the field works in that area.
Yeah.
So we had something to write on the map on the graph.
The way we do a cross section is by putting taking it across, and then at regular intervals, weekly cycle intervals, we just measure the depth down on that and then when we can actually then go and draw it on a bit of graph paper, work out how many meters squared the cross section is, and then maybe Mr. Albastri can do some calculations and look at the angle of, well, I don't know how you're going to do it, but work out what the velocity, potential velocity should be.
We were basically trying to measure the manifold discharge in relation to like flooding risk of previous case studies we studied, for example, like Boscastle. But the thing was, Boscastle is a running river. Like here, we had a wadi that was completely dry, so we couldn't even measure the velocity. And
Mr. Albastri was trying to be genius and was he did similar triangles. Kind of went on. I don't know what he did there, and then he went on and
we tried to calculate the velocity,
and he found out it was 4 meters per second, which we thought was really, it was too quick for just a running river. But when there's a flash flood in the Wadi, it seems quite true. But Mr. Rees didn't actually believe Mr. Albastri when he figured out that it was 4 meters per second.
Okay. So let's just go and have a little wander around. We'll decide where we're going to do the cross sections. We can do a couple because we've found it plenty of time.
The water flows down from the mountain, doesn't it?
Yeah.
I don't have the water. We can estimate the height of the mountain.
I brought a thermometer.
Yeah, we can work out the height of the mountain. We'll work out the drop potential energy.
You need to know the catchment area as well, though.
We can estimate that. We'll copy off the map.
We can. Yeah.
Easy, please.
Yeah. All right. This is why I brought him.
And it was funny because, to be honest, I thought there was going to be water. So, but there was no water, so it was pretty like.
It was dry.
And it was so deep, like. So then we had to sort of go down into the wadi, and it was funny. I got down first, and then I got down first.
I don't like climbing.
And then I looked up, and the coaster was still at the top. It's gonna take another 10 minutes for her to get down. So anyways, we're at Wadi Ham. Not really sure if it is Wadi Ham itself, but we're at a wadi, and yeah, we're gonna measure a couple of things like cross section, and then from that we create a map of it. No, not a map, sorry, a graph. And then we're gonna try and measure its velocity, its catchment area, and its discharge, and probably other things which I didn't really remember listening to. But anyways, okay, making progress, guys. Woohoo!
This is formed basically the river. It's taken some rocks down and it's laid all the sediment down on the valley bed. It might have been at a time when there was, say, more rainfall, so the river flow was more constant. And you can see it's made up of different types of sediment. You've got quite sort of sandy, muddy material, and then you've also got much larger material in it. Now, currently, you can see what's happened is the Wadi has cut down through that layer of sediment. This sediment would have been going all the way over to the other side, but the Wadi, every time it floods, obviously it eats the channel. A bit like you know the way a delta, it drops its material and then it makes its own little distributaries in the delta. That's what's happened here. It's been obviously all this is sedimentary rock, and the Wadi's cut through it. If you go further up here, you see there's much different type of rock. This rock, see, it's probably metamorphic rock, and much, obviously you can see it's not crumbly at all. So what's happened to the size of the channel in the area where the rock is much
becomes
more
thinner.
Much more narrow, yeah. And like you probably describe that as a mini gorge, very steep-sided channel. So what we're going to do, we're going to measure one across the gorge, and then we're going to measure one across here. Mr. Abbas is going to get like GPS, so then we know we can plot on the map exactly where we took the cross sections of the channel. All right? Okay.
Okay, so we got to the top of the mountain and we could see like military base, so I was kind of like freaked out to
Because Mr. Abbas into him, but they might come and shoot us.
Pretty much.
Spying on military base.
And so that being at the top of the mountain pretty much helped us with our hazard risk map. So that was we looking at GIS maps of the area, pretty much just estimated as to like how much of area would flood and how much the land's worth and stuff.
Yeah.
And that was pretty much it for our Wadi Ham investigation on flooding.
Yeah, it was good.
Yeah.